Today we are starting something new on this channel, a Docker interview series. And this is part one, the fundamentals. So if you're preparing for a backend role, a DevOps role, a cloud role, anything really Docker questions are going to come up, almost guaranteed. So let us just go through them one by one and I will tell you exactly what to say. All right, let us get into it. First question. And this one is super common, like almost every interview starts with this: what is Docker? Okay, so Docker is a tool that packages your application and all of its dependencies into something called a container. Now, what does that actually mean, right? So think of it this way: everything your app needs to run, the code, the libraries, the config files, all of it is bundled together inside that container. Like imagine putting your entire app into a box, and that box has literally everything it needs to survive on its own. And because of that, it runs exactly the same on any machine, your laptop, a test server, production, identical behavior everywhere. Now, you know that classic situation, right? Where something works perfectly fine on your machine, but the moment it hits a server, it just breaks and you're sitting there like, what? It worked 5 minutes ago? Yeah, that is exactly what Docker fixes. And on top of that, containers are way faster to start, like way faster, and they use way less memory than virtual machines. So compared to a VM, Docker is just leaner, lighter, faster. So to bring it all together, Docker packages your app and everything it needs into a portable container that runs consistently. Anywhere, that is your answer: clean, clear. And trust me, that covers everything an interviewer needs to hear. Okay, so question 2, and this one, most people get wrong, like genuinely, what is a container? Now, a lot of people say, oh, it is like a mini virtual machine, and look, I get why people say that. But that is not really the right answer. And interviewers know the difference. So let us get this right. A container is an isolated running process on the host machine. That is it, just a regular process that has been isolated from everything else. Now, how does Docker actually make that happen? 2 Linux features, and knowing these is what separates a good answer from a great one. First one, namespaces. Namespaces give the container its own view of the file system, its own network, its own list of running processes. So from inside the container, it feels like it is completely alone on the machine, like its own little world, nothing else exists. Second one, cgroups. Now cgroups control how much CPU and memory the container is actually allowed to use. So it cannot just hog all the resources and starve everything else on the machine. Keygroups put a leash on it. Now here is the big thing, and make sure you say this: there is no separate operating system, none. The container shares the host machine's kernel directly, and that is what makes it so much faster and so much lighter than a virtual machine. No separate OS to boot up, no extra memory overhead, just a process, a fast, isolated, lightweight process. So to bring it all together, a container is an isolated process on the host machine. Namespaces give it isolation, its own file system, network, process list, key groups limit its resource usage, and it shares the host kernel directly, no separate OS. That is why it is faster and lighter than a VM. Say namespaces and C groups out loud in your interview. Because most people just say isolated environment and leave it there. Going one level deeper, showing the actual Linux features underneath, that is what stands out, and that is the difference. All right, question 3, and honestly, this one comes up all the time. Like I have seen this in almost every single Docker interview. So pay attention to this one. What is the difference between a container and a virtual machine? Okay, so let me walk you through this properly. So first, a virtual machine, a VM, runs a full guest operating system, like a completely separate OS, on top of something called a hypervisor. And because of that, it is heavy. We are talking gigabytes of disk space and boot time minutes. Like you spin up a VM and you're just waiting. Now a container is completely different. A container shares the host kernel directly. There is no guest operating system at all. None. So it is lightweight, just megabytes, and startup time milliseconds. Like you blink, it is running. That is the difference in feel between the two. Now here is the part, and I really want you to remember this. Make sure you say this in your interview, because this is what separates a good answer from a great answer. The trade-off: virtual machines have stronger isolation. Why? Because each one has its own completely separate operating system. Nothing is shared. Containers, on the other hand, share the kernel. So isolation is at the process level, not the OS level. Now, does that mean containers are worse? No, not at all. It just means they are different. Both are valid. Both have their place. And here is something really interesting. In most cloud setups today, you actually have both running together. Like at the same time, your containers are running inside virtual machines on AWS or Google Cloud or wherever. So it is not really an either or situation. It is more like VMs give you the infrastructure layer and containers give you the application layer. They work together. So to wrap it up, VMs full OS, heavy, slower, stronger isolation. Containers shared kernel, lightweight, fast process level isolation. And in the real world, you will almost always see both. That is your answer. All right, so question 4, what is a Dockerfile? Okay, so simple answer: a Dockerfile is a recipe. That is it, a plain text file with instructions that Docker follows top to bottom to build your image. Now the key instructions, first one, from always. The very first line, always, it sets your base image, node app, from node Python app, from Python. That is your starting point. Next, run executes commands during the build, things like npm install or apt-get install. Then copy brings files from your machine into the image, your source code, your config files, all of it. Work there, think of it like cding into a folder, sets your working directory inside the container. And finally, cmd runs when the container starts, not during the build. When it starts, node server.js, python app.py, whatever kicks off your app. That goes in cmd. Now the part that impresses interviewers, layer caching. Every instruction creates a cached layer if nothing changes. Docker just reuses it, skips it completely. Real example, you change one line of code without caching. Docker reinstalls everything, every single package from scratch every time, slow, really slow. But if you copy package.json first before your source code, these nothing change and skips it, only rebuilds what actually changed, that is layer caching. So to wrap it up, from sets the base, run executes commands, copy brings in your files, work dir ir sets the folder, cmd runs on container start, and always mention layer caching, copy package.json before your source code. Say that in the interview because that one detail shows you actually understand Docker, and that is the difference. All right, so question 5. What is a Docker image? Okay, so simple answer, an image is a read-only template, a snapshot of exactly what your container should look like. It is built from a Dockerfile and it is made of stack layers, one layer per instruction. Once it is built, it is immutable. You cannot change it. You store it in a registry like Docker Hub, share it with your team, or pull it onto your servers for deployment. Now, here is the key thing. One image can create as many containers as you want, all running at the same time. Now, the analogy that makes this click in an interview, an image is like a class in programming and a container is an instance of that class. The class is the blueprint, the instance is the running thing. One class, many instances, same exact idea here. So to wrap it up, an image is a read-only template built from a Docker file made of layers, immutable ones built, stored in a registry, and one image can run as many containers as you need. Use that class and instance analogy, say it out loud in the interview because that one line shows you actually understand the concept. All right, so question 6, what is Docker Hub? Okay, so simple answer, Docker Hub is a cloud-based registry for storing and sharing Docker images. Think of it like GitHub, but for images, it hosts official images for all the common tools, nginx, Postgres, Node, Redis, all of that. And when you run docker pull nginx, that command goes to Docker Hub by default to fetch that image. Now, here's the real world part. Most companies do not use Docker Hub for their own application images because it is public. Instead, they use private registries. AWS has ECR, Google Cloud has Artifact Registry, and there is GitHub Container Registry, which is really popular for open source projects. Now, the workflow is the same regardless of which registry you use. Build, tag, push, pull, that is the cycle, and that is what interviewers want to hear. So to wrap it up, Docker Hub is a cloud-based registry like GitHub, but for images, hosts official images for common tools. And in real companies, private registries are used instead. AWS ECR, Google Artifact Registry, GitHub Container Registry, build, tag, push, pull, know that cycle, say it in the interview. All right, so question 7, what is the difference between CMD and entry point? Now, this one trips people up a lot. Both define what runs when the container starts, but they behave very differently. Let us break it down. CMD sets a default command, but it can be completely overridden at runtime. So if your Docker file has cmd node index.js, but you run the container with python script.py, Docker just throws away cmd and runs the Python script instead, completely replaced. Now, entry point is different. Entry point is the fixed executable that always runs no matter what. You cannot replace it from Docker run. You can only change the arguments passed to it. Now, here is where it gets interesting. When you use them together, entry point is the command and cmd provides the default arguments. So entry point is node and cmd is index.js. You can pass a different file name at runtime, but it will always use node to execute it. Always that combination is the best practice. So to wrap it up, cmd is the default command, can be fully overridden. Entry point is the fixed executable, cannot be replaced, only its arguments can change. Use them together, entry point as the command, cmd as the default arguments. Say that in the interview because most people cannot explain the difference clearly. All right, so question 8, what is Docker Compose? Okay, so in real apps, you never run just one container, never. You have your application, your database, maybe Redis, maybe nginx, all running together. Now managing all of those with separate Docker run commands is honestly a nightmare. Compose solves that. It is a tool for defining and running multi-container applications. Everything goes into one file, docker compose.yml, all your services. The networks they use, the volumes they need, and the dependencies between them. So Docker knows which order to start things in, then Docker compose up starts the entire stack with one command, and Docker compose down stops and removes everything cleanly. Now this part is important. Be very clear about this in your interview. Docker compose is for local development and testing. That is it. It is not a production orchestration tool for production at scale. That is Kubernetes. Say that distinction out loud because most people do not. So to wrap it up, real apps run multiple containers. Compose puts them all in one YAML file. Docker compose up starts everything. Docker compose down stops everything. And compose is for local development, not production. Production is Kubernetes. Say that in the interview because that one distinction shows you understand the bigger picture. Question 9. What are Docker volumes? Okay, so here is something that catches a lot of beginners off guard. Containers are ephemeral. What does that mean? When a container stops or gets deleted, all the data written inside it is completely gone, wiped. That is a massive problem, especially if you're running a database. Volumes fix this. They store data outside the container. Docker manages it on the host machine, so the data survives, restarts, deletions, all of it. Now, there are three types. First, named volumes. These are managed entirely by Docker. Use these in production. Second, bind mounts. You map a specific folder on your host machine directly into the container. Great for local development because file changes are instant. Third, 10pfs mounts. These only exist in memory, never written to disk at all. Now, practical tip, and this is important. If you're running Postgres or MySQL in Docker, always use a named volume for the data directory. Always, if you skip that, every container restart wipes your entire database, gone. So to wrap it up, containers are ephemeral. Data is lost when they stop. Volumes fix that. Three types: named volumes for production, bind mounts for local development, 10 MPFS for memory only data, and always use a named volume for your database. Say that in the interview because that practical tip shows you have actually used Docker, not just read about it. Okay, so question 10, and this one is pretty interesting actually. What is Docker networking, right? So when you have multiple containers running, how do they actually talk to each other? That is exactly what this question is asking. Let us get into it. The default driver is bridge networking. Now, what does that mean? Containers on the same bridge network can reach each other using the container name as a host name. Docker handles all the DNS resolution behind the scenes. So imagine this, your app needs to connect to your database. You just use DB as the host name. That is it. No IP addresses, no manual configuration, nothing. Docker just figures it out. Pretty neat, right? Now, there are other types as well. Let us go through them quickly. Host networking. The container shares the host machine's network stack directly, zero isolation. Then we have overlay. This one is for containers spread across multiple machines. That is what Kubernetes and Docker Swarm use. Under the hood, and then there is none, which just completely disables networking for containers that simply do not need it. Now, here is something really useful to know. In Docker Compose, all your services are automatically placed on the same bridge network. So they can reach each other by service name straight away, no extra setup, no extra config, just works out of the box. So let us bring it all together. Bridge is the default. Containers talk using container names as host names. Host shares the network stack directly. Overlay handles multi-machine setups. None disables networking completely. And in Docker Compose, everything sits on the same bridge network. Automatically mention that in your interview because a lot of people know what Docker is, but not how containers actually communicate, and knowing that sets you apart. Okay, so question 11, and this one is actually a really common trap. What is the difference between copy and add, right? So both copy files into your Docker image and they look almost identical, which is exactly why people mix them up. Let us break it down. Copy, simple, predictable. It copies local files or directories from your machine into the image, and that is all it does, nothing else. Now add does the same thing, but with two extra abilities. First, it can download a file directly from a URL into the image. Second, it automatically extracts tar archives when you copy them in. Now, you might be thinking, why not just always use add then, right? Here is the thing though, the Docker documentation actually recommends against that because add's auto extraction behavior can produce unexpected results and makes your Docker file harder to read, harder to understand, harder to maintain. So the safe rule is this: always use copy default to it every time, only reach for add when you specifically need URL fetching or automatic tar extraction. That is it. So to bring it all together, copy is simple and predictable, local files only, nothing extra. Add has extra powers, URL fetching and tar extraction, but use it only when you actually need those features. Default is always copy. Say that in your interview because most people just say they do the same thing and move on knowing the difference and knowing when to use each one. That is what actually stands out. Okay, so question 12. And honestly, this one is a bit of a secret weapon. What is a multi-stage build? Now, here's the thing. You want to bring this one up proactively without even being asked because it immediately shows that you care about production quality, not just making things work, but making things work well. So let us get into it. The problem first, building an app requires a lot of tooling. Compilers, build systems, package managers, all of that. But here is the thing, none of that tooling is needed to actually run the app, none of it. So without multi-stage builds, your final image carries all that dead weight. All those tools just sitting there making your image massive. For no reason, multi-stage builds fix that. They let you use multiple from statements in one single Docker file. Here is how it works. Stage 1, you use a full image with all your build tools, you compile your app. You bundle everything all inside stage 1. Stage 2, you start completely fresh from a tiny base image and you copy only the compiled output from stage 1. That is it, just the output, nothing else. All the dev tooling from stage 1 gets thrown away completely. Gone, and the result is a dramatically smaller production image. Like I have seen this take a 1.2 gigabyte image down to 45 megabytes. That is not a small difference, that is enormous. So to bring it all together, multi-stage builds use multiple from statements. Stage 1 builds the app with all the tools. Stage 2 starts fresh and copies only the output. Dev tooling gets left behind completely. And your final image is tiny fast. Clean mentioned this in your interview without being asked, because most people wait to be asked about it. And that one moment of bringing it up yourself is a real green flag, right? So question 13, and this one is really practical, like genuinely useful in your day-to-day work. How do you reduce Docker image size? Now there are a few techniques here, and the cool thing is doing all of them together really compounds the effect. So let us go through them one by one. First one, use Alpine based images. So instead of from node 18, you write from node 18 Alpine, and just from that one change, you go from over 300 megabytes down to about 5 megabytes. Just like that, one line, massive difference. Second, multi-stage builds. We talked about this in the last question. Build your app in a full image with all your tools, then copy only what you actually need to run it into a tiny final image. Everything else gets left behind. Third, chain your run commands. Instead of writing separate run lines, connect them with double ampersand. Why? Because every separate run instruction creates a new layer, and if you delete something in a later layer, it is still baked into the previous one. Chaining them keeps it all in one layer. Clean. Fourth, use a .dockerignore file. This stops node modules, .git test files, all of that unnecessary stuff from going into the build context at all. Think of it like a .git ignore, but for Docker. Fifth, always remove package manager caches. In the same run step, you install them, not after in the same step. Otherwise, the cache still lives in that layer. Now do all 5 of these together, and honestly, you can take a 2 gigabyte image under 50 megabytes. That is the kind of result that impresses people. So to bring it all together, Alpine based images, multi-stage builds, chain your run commands, use .dockerignore, and remove caches in the same step. 5 techniques all compounding on each other. Mention all 5 in your interview, because most people know 1 or 2. Knowing all 5 and how they work together, that is what stands out. Okay, so question 14. And this one is actually really important, like not just for performance, but for security as well. What is .dockerignore, right? So when you run Docker, build Docker packages your entire project folder and sends it to the Docker daemon as the build context. Now, without a dockerignore file, that includes everything, and I mean everything. Your node modules folder, which can be hundreds of megabytes, your .git directory, your .env files with API keys and passwords, your test suite, your logs, all of it, just getting bundled up and sent across. Now, a.dockerignore file works exactly like .gitignore. You list what to exclude, and Docker leaves those out completely. Simple as that. At minimum, you want to exclude these node modules, .git, any .env files, test folders, and logs, those 5 at least. Now, here is the part most people miss. There are 2 benefits, and both of them matter. First, faster builds, because less data is being sent to the daemon, less to process, less to transfer faster. Second, and this one is big, more secure images, because you avoid accidentally baking sensitive credentials into your image and potentially pushing them to a registry where anyone could access them. That is a serious security risk, and .dockerignore prevents it. Now, make sure you mention that security point in your interview, because most people only talk about the performance side. Bringing up security shows you think beyond just making things work, and that is exactly what interviewers want to see. All right, so question 15, and this one is more important than it looks. What is the difference between Docker stop and Docker kill now? Both stop a running container. That part is the same, but how they stop it, that is where it gets interesting. And that difference really matters in production. So let us break it down. Docker stop, this is the graceful way. It sends something called a SIGTERM signal to the main process. Think of it like a polite heads up. Hey, please wrap up what you're doing and shut down cleanly. Now, a well-written app catches that signal and does its cleanup. Finishes in-flight requests, closes database connections, flushes writes to disk, all of that. And if the app does not stop within 10 seconds, Docker automatically sends SIGKILL and forces it to stop, but it gives it that chance first. Now Docker kill, this is completely different. It skips all of that, goes straight to kill immediately, no warning, no grace period, no chance to clean up, just gone. Now here is the practical part in production. You always want Docker stop, always, because your app needs that time to finish what it is doing. To close connections properly, to not lose data, you only reach for Docker kill. When a container is completely frozen and not responding to stop anymore, that is the only time. So to bring it all together, Docker stop is graceful, sends term, first gives the app 10 seconds, then forces it if needed. Docker kill is immediate, straight to kill, no cleanup, no warning. Production always uses Docker stop. Docker kill is the last resort. Say that in your interview, because understanding signals and graceful shutdowns shows you actually think about what happens in a real production environment. And that is the difference. Okay, so question 16, and this one is super practical, like genuinely you will use this one all the time. What is Docker exec, right? So Docker exec lets you run any command inside a container that is already running. You are not creating a new one, you are jumping into a live one. And honestly, this is probably the Docker command you will use most in your day-to-day, especially when something is broken and you need to look inside. Now, the most common use by far is opening an interactive shell. You type docker exec -it my container bash. Now the -i flag keeps stdin open, so it is interactive, and -t allocates a terminal. So you get a proper shell experience, and now you're inside. You can explore the file system, check what is running, look at config files, debug whatever is broken right there inside the live container. Now you can also run quick one-off commands without opening a full shell, like docker exec my container env, which dumps all the environment variables. Really useful, really quick. Now, one thing to watch out for, and this trips people up, if your image is Alpine based, bash might not be installed. So instead of bash, use just swap bash for and it works fine. So to bring it all together, docker exec runs commands inside a running container. Most common use is opening an interactive shell, -it for interactive terminal. You can also run one-off commands without a full shell. And if bash is not available, use h instead. Mention that Alpine tip in your interview, because it shows you have actually been inside containers, not just read about them. Okay, so question 17, and this one is a debugging superpower. Like genuinely, once you know this command, you will reach for it constantly. What is docker inspect, right? So when something is misbehaving and you need to understand exactly what Docker thinks is going on. Docker inspect is your best friend. You run docker inspect followed by a container name or ID, and it dumps out a massive JSON object with everything about that container, everything. The IP address, what ports are mapped, what environment variables are set, what volumes are mounted, what network it is connected to, what the restart policy is, all of it right there in one command. Now, here is something useful to know. It works on images too, and networks and volumes, not just containers. So whatever you need to inspect, docker inspect can handle it. Now, the format flag, this one is really handy when you only want one specific piece of information. Instead of scrolling through pages of JSON, you can do something like docker inspect format network settings.entrypicas my container, and it pulls out just the IP address, nothing else. Clean, straight to the point. Now, when should you reach for docker inspect? Debugging networking issues, checking that environment variables got injected correctly, verifying volume mounts. Anytime you need to know exactly what Docker is doing, that is when you use it. So to bring it all together, docker inspect dumps everything about a container, IP address, ports, environment variables, volumes. Networks works on images, networks volumes too, and the format flag lets you pull out just what you need. Mention docker inspect in your interview, because knowing your debugging tools shows you have actually worked with Docker in a real environment. Okay, so question 18, and this one is a step up. This is where things get really interesting. What is the difference between image layers and the container writable layer? Now, getting this right shows you actually understand how Docker works under the hood, not just on the surface. So let us get into it. Docker images are built from read-only layers, one layer per instruction in your Dockerfile. These layers are immutable, meaning they cannot be changed ever. And here is the part that is really clever, they are shared. So if 10 containers are running from the same image, they all share those same read-only layers in memory. Docker does not copy the image 10 times, not even close, just one set of layers shared across all 10 containers. Really efficient. Now when a container starts, Docker adds one thin writable layer on top of all those read-only layers, just one, and any changes made inside the running container, creating files, editing configs, writing logs, all of that goes into that writable layer. The read-only layers underneath are never touched, never modified. Now here is the important part. When you stop and delete the container, that writable layer gets deleted with it. Gone, which connects directly to why volumes exist. Anything you want to survive has to be in a volume, not written into the writable layer, because the writable layer does not survive. So to bring it all together, images are made of read-only layers. one per Dockerfile instruction shared across all containers running from that image. When a container starts, a thin writable layer is added on top, changes go into that writable layer. And when the container is deleted, that layer goes with it. Volumes are how you make data survive. Say all of that in your interview because most people know what layers are, but not how they are actually shared or how the writable layer connects to volumes. Knowing that full picture, that is what stands out, and that is the difference. Okay, so question 19, and this one is really important, especially if you're going for a DevOps role. What is Docker Swarm, right? So once you are running containers in production, you need something that manages them across multiple machines, restarts them when they crash, scales them when traffic spikes. That is called orchestration. Now, Docker Swarm is Docker's built-in solution. It turns a group of Docker hosts into a single managed cluster. Think of it like instead of managing 10 machines separately, Swarm treats them all as one, and you just tell it what you want. Like, I want 3 replicas of this service running. And Swarm figures out where to put them across your machines automatically. Now, if a container crashes, Swarm restarts it. If a whole machine goes down, Swarm moves those containers to the surviving machines. Without you doing anything, it handles scaling, load balancing, rolling updates, all of it. Now, here is the honest answer, and make sure you say this in your interview. Swarm is simpler to set up than Kubernetes. Much simpler, but the industry has pretty much moved to Kubernetes for production orchestration. That is just the reality. Now, does that mean Swarm is useless? No, not at all. For smaller setups or teams that want something quick and simple, Swarm is a solid choice, but at scale, Kubernetes wins. Knowing both and being able to explain that trade-off clearly is exactly what the interviewer wants to hear. So to bring it all together, orchestration manages containers across multiple machines. Docker Swarm is Docker's built-in orchestration tool. It handles restarts, scaling, load balancing, rolling updates. Swarm is simpler than Kubernetes, but the industry standard for production is Kubernetes. Say that trade-off out loud, because most people just define Swarm and stop there. Explaining the trade-off shows you understand the bigger picture, and that is the difference. Okay, so question 20, and honestly, this one confuses beginners more than it should. What is the difference between Docker run and Docker start, right? So let us break it down simply. Docker run creates a brand new container from an image and starts it. Every single time you call it, you get a completely fresh container, brand new, never existed before. Now, Docker start is completely different. It takes a container that already exists, but is currently stopped and starts it back up. Nothing new is created, nothing, just waking up something that already existed. So think of it this way. Docker run is create plus start combined in one command. Docker start is just start an already existing stopped container. That is the whole difference. Now, let me walk through the full lifecycle, because this is what interviewers really want to hear. Docker run creates and starts the container. Docker stop stops it. But here's the thing. The container still exists after Docker stop. It is just stopped, not deleted. And Docker ps-a shows you all containers, including the stopped ones. And Docker start brings a stopped container back without creating a new one. Now in practice, most people use Docker Compose, which handles all of this automatically. But knowing this distinction shows you understand the full container lifecycle properly. So to bring it all together, Docker run creates and starts a fresh container. Docker stop stops it, but it still exists. Docker ps-a shows all containers, including stopped ones. Docker start brings a stopped container back, and Docker run is create plus start combined. Say that lifecycle out loud in your interview, because most people just define Docker run and leave it there. Walking through the full lifecycle shows you actually understand how containers work, and that is the difference. Okay, so question 21, and this one ties everything together. What is a Docker registry, right? So simple answer first, a registry is a server that stores and distributes Docker images. Think of it like npm for packages or GitHub for code, but for images. Same concept. Now Docker Hub is the default public registry, and when you Docker pull anything, it is fetching from there by default. Now here is the real world part. In most companies, you do not want your own application images sitting on a public server for obvious reasons. So teams use private registries. AWS has ECR, Elastic Container Registry. Google Cloud has Artifact Registry. There is Azure ACR and GitHub Container Registry. Google Cloud has Artifact Registry. There is Azure ACR and GitHub Container Registry, which is really popular for open source projects. Now here is something really important to mention. The workflow is always the same regardless of which registry you are using. You build your image, tag it with the registry address, push it up, and then your servers or your deployment pipeline, pull it from there, build, tag, push, pull. That is the cycle every time. Now, why does this matter in an interview? Because this workflow is fundamental for any CI/CD question, like how does your app get deployed? What happens when you push code? How does the new image get to production? The answer always involves this cycle: build, tag, push, pull. So to bring it all together, a registry stores and distributes Docker images. Docker Hub is the default public registry. Companies use private registries: AWS ECR, Google Artifact Registry, Azure ACR, GitHub Container Registry, and the workflow is always build, tag, tag, push, pull. Know that cycle, say it in your interview, because that one workflow connects Docker all the way to deployment, and that is the difference. Okay, so question 22, and this one is probably the most misunderstood instruction in Docker. What does expose do in a Docker file, right? So let me clear this up properly, because a lot of people get this wrong. People see expose 3000 and they think, okay, cool, my container is now accessible on port 3000 from my browser. And it is not at all. Expose is purely documentation. That is it. It is just saying, hey, this app intends to listen on port 3000 inside the container. That is the whole thing. It does not open any port. It does not make anything reachable from outside. Nothing. Now, to actually publish the port, you need the -p flag. When you run the container, like docker run -p 8080:3000 myapp, that maps port 8080 on your host machine to port 3000 inside the container. Th is what actually opens it up. Th is what makes it reachable, not expose. Now, is expose completely useless then? No, it is still worth writing in your Docker file. For two reasons. First, it communicates intent to other developers reading the file, like a hint, hey, this app uses port 3000. Second, tools like Docker Compose use it as a reference, but on its own at runtime, it does nothing. So to bring it all together, expose is documentation only. It does not open any port. It does not make anything reachable. To actually publish a port, use -p in your Docker run command. That maps host port to container port, and that is what actually opens it up. Say that in your interview, because most people think expose actually does something. Knowing the difference between documentation and actual port publishing, that is what stands out, and that is the difference. Okay, so question 23, and this one is something you will use every single day in local development. What is docker compose.yml, right? So simple answer first, it is a YAML file that defines your complete multi-container application, all your services, the networks they use, the volumes they need, all in one place, one file, everything now. For each service you define, you specify a few things: what image to use or which Docker file to build from, what ports to map, what environment variables to inject, what volumes to mount, and depends on which controls the startup order. Now that last one is really important, because without it, your app might try to connect to a database before the database is even ready and just crash. Depends on fixes that it makes sure things start in the right order. Now once your file is set up, you just run docker compose up and it reads that file and starts your entire stack in the right order with one command, one. And docker compose down stops and removes everything cleanly. Now think about what this replaces. Instead of remembering 5 different docker run commands with all their flags and arguments and port mappings, you have one file and 2 commands. Docker compose up, docker compose down, that is it. And honestly, it genuinely transforms the local development experience like completely. So to bring it all together, docker compose.yml defines your entire multi-container app, services, networks, volumes, all in one file. Each service has its image, ports, environment variables, volumes, and dependencies. Docker compose up starts everything, docker compose down stops everything, one file, 2 commands. Say that in your interview, because it shows you actually use Docker in a real development workflow, not just in theory, and that is the difference. Right, so question 24, and this one is actually really satisfying once it clicks. How do containers communicate in Docker Compose? Okay, so here's what happens behind the scenes. When you run docker compose up, compose automatically creates a network and places all your services on it, every single one, automatically without you doing anything. Now each service becomes reachable using its service name as a hot name. Docker handles all the DNS resolution internally. So think about this. If your database service is called DB in the compose file, your application connects to it using DB as the host name, like postgres://db:5432/myapp, and it just works. No IP addresses, no manual configuration, nothing extra, just the service name. That is it. Now, this is exactly why environment variables like db_host equals db work right out of the box in compose, because db is literally the hostname Docker assigns to that service on the network. Pretty neat, right? Now for more complex setups, you can define custom networks in the compose file. If you want certain services isolated from others, like maybe your frontend should not talk directly to your database, you can enforce that with custom networks. But honestly, for most applications, the automatic shared network is all you need. So to bring it all together, Docker Compose automatically creates a shared network. All services are placed on it automatically. Each service is reachable by its service name as a hostname. Docker handles DNS resolution internally. No IP addresses needed, and for complex setups. Custom networks give you more control. Mention that service name as hostname part, because most people just say containers can talk to each other, but explaining how with the DNS and service name detail, that is what actually impresses, and that is the difference. Okay. So last one, question 25. And honestly, this is a great one to end on because it ties everything together. What actually happens when you run Docker build, right? So Docker reads your Dockerfile from top to bottom and executes each instruction one by one. Now for each instruction, it checks the build cache first. If that layer has not changed since the last build, Docker just reuses the cached version and moves on instantly. That is what makes builds fast after the first one. Now, but if a layer does change, Docker rebuilds that layer and every single layer after it, every one, which is exactly why order in your Dockerfile really matters. Let me give you a real example. If you put copy dot near the top, any code change, any single line invalidates every layer below it, including your npm install. So you are reinstalling all packages on every single build every time. That is slow, really slow. But if you copy package.json, first install your dependencies, then copy your source code, only the last layers get rebuilt when your code changes and the dependency install stays cached. That one change in order can save minutes on every build. Now, once all instructions are done, Docker produces a tagged immutable image ready to push to a registry or run locally. So to bring it all together, Docker reads the Dockerfile top to bottom, checks the cache for each instruction, reuses cache layers if nothing changed, rebuilds from the change layer downward if something did. Order matters because of cache invalidation. Copy package.json before your source code. Always, and the final result is a tagged immutable image ready to ship. Say all of that in your interview. Because understanding the build process, cache invalidation, up package.json before your source code, always, and the final result is a tagged immutable image ready to ship. Say all of that in your interview, because understanding the build process, cache invalidation, and why order matters shows you do not just use Docker, you actually understand it, and that is the difference. And that wraps up all 25 questions. You now have everything you need. Go get that job. And that is it, 25 Docker questions, done. Now look, if you made it all the way here, you're already ahead of most people walking into that interview. Like genuinely, most candidates know maybe 5 or 6 of these. You just went through all 25. That is the difference. So if this helped, hit subscribe because part 2 is coming and it goes even deeper. Docker Compose in-depth networking. Multi-stage builds all of it, the stuff that separates good answers from great ones. So stick around and I will see you there.